Hello, everyone, and welcome. Today, I would like to talk about linear regression. In particular, I would like to talk about coefficient estimates. It's a very important topic, so let's get started. First of all, I would like to describe some key descriptive statistics. First, variance. Variance is how much a dataset are spread out around their mean value. And here is a formula for the sample variance. Importantly, the unit of variance is S squared. Second, I would like to describe covariance. Covariance is how much two random variables tend to move in the same or inverse direction. It is a measure of the joint movement direction. It has the unit of x, y. Here's the formula of the sample covariance. With the concepts of variance and covariance in mind, now let's talk about simple linear regression. The equation is y, the dependent variable, equals to alpha, the intercept, plus beta, the regression coefficient, times x. X is the independent variable. How do we interpret beta? Well, the unstandardized beta means the expected change in y in natural units of y due to an increase in one natural unit of x. Importantly, to estimate beta, we use ordinary least square, where beta is the covariance of x and y over the variance of x. This expression, the covariance of x and y over the variance of x, can also be re-expressed in terms of the correlation coefficient Rxy times the standard deviation of y over the standard deviation of x. This part, the standard deviation of y over the standard deviation of x, means the ratio of the natural unit of y to the natural unit of x. And the correlation coefficient means the magnitude of association between x and y. Therefore, beta can also be understood in this way. Interestingly, if you swap x and y, then the unstandardized beta will be Ryx times the standard deviation of x over standard deviation of y. Therefore, the product of the two unstandardized beta will be R squared. And we know R squared has a range between 0 and 1. Now, if we standardize the variance of x and y to be 1, then we will have a standardized beta. Now, the estimate for the standardized beta is given by the covariance of x and y over the product of the standard deviation of x and the standard deviation of y. Just like the interpretation in the unstandardized beta, the standardized beta can be interpreted as the expected change in y, but now in units of the standard deviation of y due to an increase in one standard deviation of x. It therefore becomes natural unitless, as the variance of the dependent variable and the independent variable are equal to 1. When there's only one independent variable, then the standardized regression coefficient beta is the same as the correlation coefficient. Because of that, the standardized beta is not particularly useful when there's only one independent variable. Now, let's talk about multiple linear regression, also known as multiple regression. So we have multiple independent variables in this case. Here, the standardized beta is a lot more useful. It means the expected change in y in units of the standard deviation of y due to an increase in one standard deviation of x, with all the other x variables unchanged. Importantly, because of being unitless, the absolute values of standardized beta may be compared, as it gives a rough indication of the relative importance of the x variables. The estimate for the standardized beta is given by The unstandardized beta times the standard deviation of x over the standard deviation of y, while unstandardized beta is estimated elsewhere using ordinary least squares. Now, let's look at how we can estimate the regression coefficients in practice. I'm going to describe three different methods. Here are the first two, using stats models and scikit-learn respectively. In stats model, you can see that if we want to estimate the standardized coefficients, we don't need to add constant for the intercept term. In scikit-learn, if you want to estimate the standardized coefficient, you just do like the unstandardized coefficient way, and the intercept term will be estimated to be 0. Please feel free to pause the video to read the information here in some more details. And here is a third method where you estimate those regression coefficients by hand. Please feel free to pause the video to read the information here in some details. Finally, here is an example where I apply the methods that we just mentioned to a marketing dataset. In this example, I use the independent variables of the advertising budgets in thousands of dollars using Facebook or YouTube to explain the dependent variable of sales. And you can see the result here for both simple and multiple linear regressions, and for both unstandardized and standardized coefficient estimates. Please feel free to pause the video and think about how you can interpret the information here in terms of what we have covered in this video. And that's all for this video. Hope you find this video to be useful. If you like, please subscribe for more videos. I'm looking forward to making more videos, so please stay tuned. Hope to see you next time soon, and goodbye.